Okie dokie. This is lesson 6.5, the last one of college algebra. It's about rational functions and where all their asymptotes are. Some of them will be some equations today. Some will be some inequalities. So we're just going to dive in. And a rational function is any kind of function where you got like some stuff in the numerator going on and some stuff in the denominator going on. Check this chart out that I have typed out for you on this paper. This is your best friend, and I won't even lie to you. It's going to be on the test. This chart will be there for you. Your job is to learn how to use this chart to help you with these asymptotes. When we take the final exam here in a few days, this chart will not be provided for you. But on this unit test that we are about to take, the chart will be there. Does that make sense? All right. So it tells you how to find vertical asymptotes, how to find horizontal asymptotes, and how to find oblique asymptotes. By far, the easiest thing around is finding vertical asymptotes. They are values of x that make the denominator 0. So would you believe in this rational function right here, there's our denominator, right? Could you tell me what value of x would make that 0? If x was -1. That's a bad guy. He's the dude that gets kicked out of the party, all of that crazy stuff that we talked about before. So that's where our vertical asymptote is. It is at the line x equals -1. Right, so we will put that there. So just remember, it's not just -1 being a vertical asymptote. It is the vertical line x equals -1, because that's what made the denominator 0. Horizontal asymptotes. Yikes! There's 3 different scenarios. I just call them like scenario A, scenario B, and scenario C going on right here. Let's see if we can understand the chart, because the chart is provided for us. Sometimes there's horizontal asymptotes, sometimes there's not. Here's when you will have no horizontal asymptotes. In situation A, there will be no horizontal asymptotes if the degree of the numerator is greater than the degree of the denominator. Cool? So it's all about the degree and numerator compared to denominator. If that's not happening, it could be choice B. There will be a horizontal asymptote literally at the line y equals 0 if the degree of the numerator is less than the degree of the denominator. And there could also be a horizontal asymptote at the line y equals whatever the leading coefficients are over each other. We'll talk about that when we get to it. If the degree of the numerator is exactly the same as the degree of the denominator. So it's all about the degree of the numerator and denominator. Who is the degree of the numerator, my friends? Biggest exponent you see is what? 1. Would you believe this has a degree 1? Right? How about the degree of the denominator? It is 1. Would you believe that those have the same degree? Please, with the neighbor, see if that's option A, option B, or option C. Which one of those has the same degree? See? It is option C, where the degrees are the same because they're equal to each other. So there is going to be a horizontal asymptote. Remember, all horizontal lines start with y equals, and it will be whatever the leading coefficient of the numerator is. Would you believe that's a 1? Isn't that the leading coefficient of the numerator? Over the leading coefficient of the denominator. So we look at those leading coefficients as like a little fraction. Would you believe that would be 1 over 1, which that is just plain old how much? 1. So it's like y equals the leading coefficients over each other. If this was a 2 and this was a 1, that would be the horizontal asymptote would be y equals 2. If this was a 3 down here, it would be at y equals 2/3. It's whatever the leading coefficients are. So it takes a little bit of practice. It's weird. As long as we know how to read the chart, we're going to be in business today. And then here is about oblique asymptotes. Remember, oblique is just not horizontal and it's not vertical in that case. It's like most people call it diagonal. It's like the real word is oblique in that case. So it's got some sort of slope to it. But that will only happen if the degree of the numerator is exactly 1 more than the degree of the denominator. So here's an extra super terrific, extra super terrific hint. If there is a horizontal asymptote, there cannot be an oblique asymptote. Right? It's just like the thing that I memorized. So that means that we will put none in this blank if my pen would work. If there is a horizontal asymptote, there will be none. Because there's only one time when you'll have no horizontal asymptotes. That's if the degree of the numerator is bigger than this guy. That's what has to happen for it to be an oblique. But it has to be 1 bigger. So that's kind of weird. Here's what I'd like to do, though. I'd like to punch this in the old calculator and see if we can get the graph to look like what it's supposed to. Just so you know, the hard part is actually punching that in the calculator. You must put the entire numerator in parentheses, and you must put the entire denominator in parentheses. We're going to need to know how to graph this stuff anyway, so please go ahead and punch that in real quick. So go ahead and graph it on the standard window, so just zoom 6. And we'll see this. I kind of got it prepared on this slide right here. Would you believe that this is what we see going on here? Which is difficult for people to look at. Let's see if things match up. Is there a vertical asymptote at x equals -1? What do you think? Is there a vertical asymptote there? Even though the calculator doesn't show it, I drew it in here. Can you kind of see, oh, I got you. This thing's like getting closer this way and getting closer that way. You with me on that? Is there a horizontal asymptote at y equals 1? Can you kind of see, even though the calculator doesn't put it in there, that there is a horizontal asymptote at y equals 1? And there is no oblique asymptotes. We'll see what that looks like later. So, all right, let's keep practicing. Back to number 2 here. The easiest thing is finding the vertical asymptotes. That's what values of x make the denominator 0. Oh no. This is a quadratic in standard form. It would be so much easier if we could write that in factored form first. So let's see. Since a is 1, isn't this easy factorable in this case? Can you find two numbers that multiply together to be -10 and add together to be trace? A 2 and 5 combo, but one of them has to be negative. Which one has to be negative? The 2 does. So what I'm going to do is rewrite this whole thing. Isn't this actually like x minus 2 times x plus 5? That's the denominator. And the numerator is still just 4. You know, we didn't do anything to the denominator. But we factored this denominator because now I can easily see who makes this 0. What value of x makes this bad boy 0? If x was? So there is a vertical asymptote right there. The line x equals 2. Then we have a second one. It will also be at who makes this guy 0. What value of x makes this 0 if x is? So x equals -5. These are the vertical lines that totally make this 0. So these are vertical asymptotes. You okay with that? I factored the denominator. Horizontal asymptotes. Let's read the chart. Which one of these scenarios, A, B, or C, is going on? The degree of this guy is 0 because there's no x's with it all together. The degree of this guy is 2. Is the degree of the numerator bigger than the degree of the denominator? Is that happening? The degree of the numerator is 0. The degree of the denominator is 2. Is part A happening? Nope. So it will not be having none. Is the degree of the numerator less than the degree of the denominator? That is happening. This is our horizontal asymptote then. It is literally at y equals 0. So there's nothing to figure out. It is just going to be at y equals 0. And will there be an oblique asymptote? Well, since we have a horizontal asymptote, there will be no oblique asymptote. So we'll put none in that blank. And if you wanted to punch that in and graph it, you totally can punch that in and graph it. We don't have to if we don't want to. There's nothing to gain, but it's just to see if we can punch it in. We'll do a lot more punching of stuff in later anyway, but you would have to put this whole denominator in parentheses. So you okay with finding those? Let's try another one. See if you can find the vertical asymptotes with your neighbor. Thoughts? X equals 2. That would be it. There's nothing to factor. It's not a quadratic. It's just a linear expression, so x equals 2. Are you okay with that? So nice. Horizontal asymptotes. Would you believe that the degree of the numerator is 2 and the degree of the denominator is 1? Those are the degrees. Isn't this guy bigger than that guy, right? So let's see. The degree of the numerator is greater than the degree of the denominator. That is happening. So guess what we got for horizontal asymptotes? We have none. And that gives us an opportunity to have some oblique asymptotes. But I just want to make sure we're okay with why there's none, is because that's what the rules say, that if the degree of the numerator is bigger than the degree of the denominator, there's going to be no horizontal asymptotes. You okay with that? Degree of, or oblique asymptotes, they may happen, they might not happen. It will only happen if the degree of the numerator is 1 bigger than the degree of the denominator. Is that happening? The degree of this is 2. The degree of this is 1. Is this guy 1 bigger than that one? So there's going to be oblique asymptotes. How do you find them? We divide. The easiest thing to do is we're just going to do synthetic division in this case. Right? So synthetic division, we will synthetically divide by what makes this 0. Who makes this 0 again? 2. So let's do a little synthetic division bracket right here. We're going to synthetically divide by 2. What should we synthetically divide by 2? The numerator. Whatever the hell the numerator is, we're going to write that with all just the coefficients. So would you believe that's a second degree polynomial? Won't I need 3 nuggets inside of here? How many x squareds are there? There are 1 of them. Would you believe there's 1 x squared? How many x's are there? There's none. How many constants are there? There are none. That's so easy that it's hard. It's one of them just plain Jane McGee's, but we're synthetically dividing to find oblique asymptotes. Divide by what makes the denominator 0. So maybe if you want to draw a little arrow to help yourself, it's like, okay, that's what made this guy 0. And this is the numerator up here in this case. Now, just do synthetic division, please. Bring the 1 down and synthetically divide. So 2 times 1 is 2. Add that up and get a 2. 2 times 2 is 4. And put our cool little remainder box, remainder of 4. Beautiful thing about this is the remainder means absolutely nothing to us. We're going to synthetically divide and ignore the remainder. So don't care. It doesn't have to be 0. Most of the time it won't turn out to be 0. I just need to know what this says. Would you agree it was originally a second degree polynomial? What the heck does this say right here? This is 1 what? X. And then isn't this your constant plus 2? Well, our oblique asymptote will be at y equals x plus 2. To be oblique, your equation of that line has to have both x's and y's in it. We know that we're going to have y equals, and it's whatever the heck that turned out to be. Weird. We will do more of that, but we synthetically divided by what made the denominator 0, and whatever we got, ignore the remainder, throw a y equals x plus 2. Sound okay with that? There's only one more weird thing, and then the rest is a piece of cake, and it's happening on number 4. Would you believe that we should probably factor this guy to be able to find our vertical asymptotes? So I'll let you guys do that real quick. Factor the denominator. Who are those two numbers that multiply together to be 5 and add together to be 6? 1 and 5, 5 and 1, and they're both positive, right? But something very strange is going to happen here. The denominator turns out to be this, which is very well. Would you believe the numerator is this in blue? And do you notice that we have a group upstairs and the exact same group downstairs? Like the same group is up and down. That's a very bad thing. Do you see that? Which group is both up and down? X plus 1s. So there will not be a vertical asymptote at x equals -1. We're going to come back to him in a second. But would you believe this x plus 5 is going to cause us a vertical asymptote? There will be one at x equals -5. But whenever you get a group on top of a group, you get what's called a hole in the graph. Before I tell you what a hole in the graph is, let me just see if you can figure it out. If I asked you to graph this, x greater than 5, on the number line, here's like 3, 4, 5, 6. Could you tell me, how would you graph it? You got to put a dot above 5, right? What kind of dot? Open dot or closed dot? Isn't there an open dot right here above 5, and doesn't it go this way? That's a hole in the graph right there. That 5 means it doesn't really count. There's just an empty spot right there. There is a hole in the graph. And a hole in the graph will always happen when you get a group exactly the same upstairs and downstairs. So what we're going to do is we're going to write it like this. We've got our vertical asymptote of x equals -5, but we're going to say we have a hole at, and then we're going to write an ordered pair. This is the hard part. What do you need? We've got to figure out what value of x makes this 0. Who's the bad guy if x was -1? Are you all cool with x being -1 is very, 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 very bad? The tough part of when we find our x value of the whole is we got to go find the y value. Here's what you do. Cancel those out, because they do. What's left in the numerator, though? It's like there can't be nothing left up there. What's left there is really the number 1. Isn't there just like 1 times this group? So there's really a 1 up there. We're going to substitute -1 into the leftovers. So if I do that, I'll just write it off to the side. I don't care if you do or don't. There's only a 1 up here. You can't substitute anything in because isn't all of that stuff gone? Right? So there's 1 up here. But if you put -1 down here, what's -1 plus 5 turn out to be? -1 plus 5 is, isn't it +4 though? Are you okay with that? +4. So this is what you get back. You get 1/4 back. That's what y turned out to be if you let x equal -1. y is going to turn out to be 1/4. So maybe let's go off to the side and write some notes for how we found the y value of the whole. Y value of the whole. Sub x value. Sub the x value back into leftovers. The leftovers are everything that's left after we crossed out the groups that's on top of each other. So we sub the x value back into the leftovers. We sub the x value back into the leftovers. We'll do some more examples after we finish this problem, but holy cow. X equals -5 is a vertical asymptote of this guy. There was a hole at this place. The hole will never show up on your graphing calculator, though. Your graphing calculator has to connect all these dots together, so it doesn't show up. The holes don't show up. So we just got to know that there was a group on top of itself. Let's do the horizontal asymptotes. I'll let you and your neighbor try that out. The degree of this is 1. The degree of this is 2. It's either scenario A, or scenario C. There? Nope, it's not this. The numerator's degree is not greater than this. Is the degree of the numerator less than the degree of the denominator? So this is it, isn't it? Y equals 0 in this case. And since there is a horizontal asymptote, is there an oblique asymptote? So there is none. Let's just not write anything down, but make up some more problems real quick. So check this out. X plus 2 over x plus 2 times x plus 3. Is there a hole in this graph? Yes or no? Yes. Let's figure out the vertical asymptotes real quick. First of all, this one's going to give me a vertical asymptote, right? Where's that vertical asymptote going to be at? At x equals -3. And the hole will be at what value of x is our bad guy? If x was not 2, but how much? -2 is the bad guy. Then we've got to substitute -2 back into the leftovers after we cross all that stuff out. Isn't there still a 1 left up here? All right, so I will have 1 over -2 goes in for x. So what do I get out of that? I get 1 back out of that situation. That is the hole at -2, 1. X plus 5 times x plus 2 over x plus 5. Will there be a hole in this graph? Yes. There are no vertical asymptotes because nothing else is going to make the denominator 0. So the hole will be at, who's the bad x value? -5. Substitute that back into the leftovers. There's a 1 down here now, right? So if we put -5 back in, all of this stuff is gone. What's -5 plus 2? -3 over 1. So isn't it just -3 in that case? So the hole is weird, but it's not as complicated as you think, just with a little bit of practice. So all right, let's see what happens. Why don't you and a neighbor try number 5? Please pause the video, see if you can get all 3 things down. The only challenge in finding vertical asymptotes is being able to factor. You know, if you still have trouble factoring, then you're going to have trouble finding vertical asymptotes. But 3 and 4, and if the 3 was negative, don't those multiply together to be -12 and add together to be +1? So this is x minus 3, and this is x plus 4. That means my vertical asymptote, first one is if x was 3. Oh, by the way, there's no holes in the graph because nothing upstairs is exactly the same as anything downstairs, so no holes in the graph. So x equals 3 is a vertical asymptote, and x equals -4 is the other one. Just for you in video land, you've got to have x equals 2 different times. You can't say x equals 3 and -4. It doesn't work that way. It's 2 different lines. So horizontal asymptote, it's always about their leading coefficients. Leading coefficient of this guy is a 2. Leading coefficient of this, degree. Degree of this guy is a 2. Degree of this guy is a 2. Aren't those degrees the same? So that puts us in this category, the third one, and that's where we go with their leading coefficients. Y is going to equal, because it's horizontal, the leading coefficients over each other, which is just what? 3 over 1, aka we'll just put 3, you know, in that situation. And then because there's a horizontal asymptote, there is no oblique asymptotes. One more. It would be nice to factor this just to see if there's a hole in the graphs, you know, because we can see if there's a group on top of a group. So let's go ahead and factor this numerator, even though he doesn't have anything to do with vertical asymptotes. He could get rid of a vertical asymptote. He could get rid of a vertical asymptote. He could get rid of a vertical asymptote just in case there was a hole in the graph. So you don't know there's a vertical asymptote at -1 until you see if there was really a hole there instead. And I believe that that numerator factors to be something like this. Isn't it 2 and 5 that multiply together to be 10 and add together to be 7? Is there a hole in this graph? There is not, because we don't get the same group upstairs and downstairs. That means that x equals -1 is a vertical asymptote in that case. Then the horizontal asymptote, it is probably better to look back here to the OG instead of this guy, because you can see the degree of this guy is bigger than the degree of this guy. So when the degree is bigger, that means that we are in option A, right? So there is no horizontal asymptote, or none. But now we got to check for oblique asymptotes. Is the degree of the numerator one more than the degree of the denominator? That is happening. So there's going to be an oblique asymptote. How do I find it? Synthetic division. Who should I synthetically divide by? What makes the denominator 0, right? So that's what we should do. Which one makes the denominator 0? -1. Take the numerator and throw all that jazz up here. Just their coefficients, 1, 7, 10, and do some synthetic division. We don't care about the remainder, though. You can actually pretty much just stop right there, because the last part is the remainder, and it's just like if we don't care, then why go further? So you can stop after you do those first two. And don't forget you need a y equals. But what is y equals? Whatever this translates back to when we put all the letters with it. What does a 1 and a 6 mean? 1x and 6 constants, right? So x plus 6. You okay with that weird stuff? Didn't make any graphs. You could always graph it on your calculator to help you, but those were equations. The last part of the worksheet is about inequalities. The chart, it's not like it's gone. It's just on the previous page if you need the chart, you know, for asymptotes and all that stuff. But you only need the chart for rational functions. Number 8 is not a rational function. Would you believe there's no x's or anything like that down in the denominator? This is just plain Jane McGee. Hey, I know it's been a little Thanksgiving break in there, but could you tell me what the degree of this thing is? This has how many zeros right here? Like, let's talk about the zeros first. What value of x is going to make this 0? -3 is a 0 of this function, right? Because it's in factored form. Will that just touch the x-axis, or will that cross over? Has it got even multiplicity or odd multiplicity? Odd multiplicity, so won't that cross over the x-axis, right? There's just 1 0 right there at -3. How about this guy? Does it have even multiplicity or odd multiplicity? This guy has, this term has even multiplicity, right? Who makes him 0? 1. And since it's got even multiplicity, will it touch over or will it cross? But I can tell, just by a lot of you who are unsure, which is fine, maybe the best thing for you to do is to graph this on the graphing calculator and see what it's supposed to look like. So let's do that. We got him punched in just the way he is. I'm going to zoom 6 him. And look at that. That there is an odd function. Can I tell you why it's odd? Because aren't the ends going different directions? One's going up and one's going down by the end behavior. It's got a 0 right here at -3. Just like I thought it was going to. It's going to have a 0 at -3. And didn't that cross over the x-axis? Take a wild guess where that 0 is at. It's at 1. And doesn't it just touch the x-axis in that case? So to make our sketch, here's what we're going to do. We're going to go put, I'm going to use a different color than blue, -3 right here. And we're going to put a 1 right here. We're going to put the zeros. Those were the zeros. And go make him look exactly like he's supposed to look, according to this guy. Doesn't it do one of these? Crosses over, turning point, point of tangency, continues to go up. Isn't that totally what that graph looks like? If you couldn't do that without a graphing calculator, big deal. You have a graphing calculator, and you could find those zeros by doing the intersection of line y equals 0. What's the purpose of doing that? is because they want to know where this thing is greater than 0 at. This is the graph and squiggle method. We have totally graphed it. Now let's do some squiggling. Where is greater than 0? Is it above the x-axis or below the x-axis? Above. So I'm not going to squiggle. I'm going to highlight, and you'll see that on my answer keys. I'm going to just highlight where this is above. I'm going to start tracing the graph. This is below, 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 below. Hello. Aren't you above the x-axis, above the x-axis, above, above, above? Ooh, interesting. What's going on right here? Is this point above the x-axis, or is it on the x-axis? On. So that doesn't get highlighted. But then would you believe that it starts to go above, 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 above again? And the crazy part is, bro, is this purple dot, does it count or does it not count in our answer? Doesn't count. So how many intervals do you see here? Is there just one interval or is there two intervals? There is totally two because we have to stop at this purple dot. So read them from left to right. How far left will this thing go? So starts way over here at -3. It's not included because there's no equal to bar. And then keep working to the right. It's going to be there, be there, be there. Where does it stop at? Stops at 1. Is 1 included or not included? Not included. There's a map as is. It's right here. We're going to start back over again at 1. And go back to infinity. This guy, here's the trick on all of these. We got to get this to be a 0 over here. So how do you move him over to the other side? Subtract. And what I need, I want to make a sketch of this guy and know where the zeros are at. This dude is not in factored form, so the easiest way to make a sketch and find the zeros is to graph him. Let's graph him and find the zeros. So it is x to the 4th take away x. Punch him in. Please do the same so you know what you're doing. Zoom 6. And that's very, very tiny. I don't know if you've ever seen on your calculator how to zoom in a little bit the very fast way instead of changing the window. So there's a couple zeros in this place right here. So the way to zoom in, obviously it's going to be in the zoom button, and it's option 2 to zoom in. So if you hit option 2, there's just a cursor flashing of where you would like to zoom in at. So the cursor, it's hard to see, but this cursor is flashing right in this region. This is pretty much where I want to zoom in at. So I'm going to hit enter, and it'll zoom in for me. And now I can see those zeros a whole lot better. How will I know exactly where they're at? I will totally graph y equals 0 and find them by intersection. So see where they intersect at. Looks like that's at 0. So let's do second calculate, choice 5, first curve, second curve, guess. Didn't do it. Come on, do it. There's the intersection at 0, 0. So 0 is a 0. And then go find that other one, please. Find the other one with the intersection tool. Looks like it's at 1. Just be for sure by doing the intersection. Second calculate, choice 5. Slide this up a little bit. First curve, second curve. 1, 0. So we got a 0 at 0. We got a 0 at 1. Make a sketch of what this graph roughly looked like. It's kind of maybe a good idea to just check it out, see what it looks like. It's really weird. It does one of these little mover McGee's, but it doesn't matter too much. And it's time to squiggle. We have done the graph. Let's do the squiggling or highlighting. I want to highlight where this thing is greater than 0 at. So I'll let you try and see if it matches mine. Where is this thing greater than 0? How do you feel about that region right there? Isn't that 2 different intervals? Please put that in interval notation real quick. Go from left to right. So as far left as this thing goes is -infinity. And then it stops at 0. Is 0 included or not included? It's all about this symbol right here. Included or not included? Not included. Bridge the gap with a union, starts back over at 1, who is also not included. Anything that's like, it's just not included. And then doesn't that go to infinity and beyond? Are you okay with those 2 intervals? Those were not rational functions at all. Those are just plain Jane McGee. The rest are rational functions. So as you can see, I brought back the the blanks for our asymptotes, and maybe a blank for our x-intercepts. Here's the important part, though. Is this homeboy, meow, 0? If he's not, we're going to have to make him 0. But right now, would you believe that this is 0? So we're going to have to graph and squiggle. And here's the crazy part. Your homework is going to have a bunch of these on here. There's only one on the practice. This guy is something we tried to get through your skull back in Algebra 2. This is a very, very fast factor. Would you believe another word for subtraction is difference? Is x squared a perfect square? Yes, it is. Is 4 a perfect square? This is called a difference of squares. Difference of squares always factors to be conjugates of the square roots. Conjugates means you're going to have two groups. One group's going to be a plus. The other group's going to be a minus. Who is the square root of x squared? X leads off each parenthesis. Who is the square root of 4? 2. One of them is a plus, one of them is a minus. Difference of squares factors to be conjugates of the square roots. So I'm requiring you to make a nice, accurate sketch of these, even though you have a graphing calculator. Making all of these blanks, filling in these blanks is going to make our sketch very, very accurate. So first, let's get some first question, are there holes in the graph? Same group up and down, do we have that going on? Nope, no holes in the graph. So vertical asymptote, x equals, it's whoever makes the denominator 0. Yep, x could be -2, and x could equal 2. Two vertical asymptotes there. Talk with your neighbor if there's any horizontal asymptotes. Is there a horizontal asymptote? This has degree 1, this has degree 2. Is there a horizontal asymptote? Choice A, B, C. Let's just put it that way. A, B, C. Which one you got? B is in the degree of the numerator less than the degree of the denominator. So it's at y equals 0. Is there an oblique asymptote then? None. So before we find the x-intercepts, let's go putting this stuff on our graph. Just freehand sketch it. You don't even need a straight edge. There is a vertical asymptote at x equals -2. So make it dashed. Put VA, x equals -2. All of this stuff is worth points on the test. There is a vertical asymptote at 2. So we'll sketch him. VA, x equals 2. And there's a horizontal asymptote at y equals 0. It's kind of weird because it's right on top of the x-axis, but we'll put it HA, y equals 0. So we'll sketch those bad boys in. There's no oblique asymptotes. To find the x-intercepts, best way for you is to probably use the graphing calculator. So we'll go to the graphing calculator and clear all this mumbo-jumbo out. To type this in correctly, you must put the entire numerator in parentheses. So we're on number 10, right? So x minus 1 divided by, put the entire denominator in parentheses. It's so much easier to go back and use that original guy, x squared minus 4, instead of putting those two, like x plus 2 and x minus 2. So just graph the original one before you factored it. You okay with that? And it should look, if you go back to Zoom 6, remember we zoomed in before, it should look exactly like what we were saying. There's a vertical asymptote at x equals -2. That's right here. There's a vertical asymptote at x equals 2. That's right here. I also have the line y equals 0 graph just because that's what we need to find this x-intercept. So let me make this large and in charge for you. What do you think about this guy right here? Is he ever going to touch the x-axis? Because we're looking for x-intercepts, this thing right here. Ever going to touch the x-axis when there's a a horizontal asymptote right there? That's not going to happen. He's never going to touch. And same thing with this guy. If we follow this branch by looking, it's never going to touch. But the weird part is you actually can touch horizontal asymptotes. This middle McGee totally crosses over that horizontal asymptote. All horizontal asymptotes do is tell you about the ends, and the ends will get closer and closer and closer to 0 as you go further and further and further. So let's do some second calculate, choice 5. And I want to see where my first curve is, where my second curve is, and just put my cursor somewhere close to this and guess and see where that intersects at. And doesn't that have an x-intercept at 1, 0 in that case? So I will put that right here. There's an x-intercept at 1, 0. And I'll put it on my sketch. Let me know if I'm going too fast, but it's at 1. I don't need the 0 part, but I'll just put at 1 right here. You okay with that? Now I'm going to just go back to my calculator and just copy the screen. This graph in the middle does some crazy crazertons like this, but it's never, ever, ever going to touch those vertical asymptotes. Vertical asymptotes are pretty much like MC Hammer. Can't touch them. There's more parts of this graph, though. This dude has a branch up here, branch up here, and it's going to just follow those asymptotes. And this other branch is down here. So we're just copying what the graph looked like from our calculator. Questions so far? Grab the highlighter or the squiggle machine, whatever you're doing, and let's highlight where this thing is greater than or equal to 0. Is that above the x-axis or below the x-axis? Above? So follow me on this branch over here. Does this branch over here ever get above the x-axis? It never does. Doesn't it stay below that asymptote the whole time? So let's go to the middle section. Is the middle section got some branches, parts of the branches above the x-axis? So we'll highlight that. Meow, 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 meow. But it stops right there. Bing! Stops there because then it would go below the x-axis. Y'all cool with that? Let's go over to the third section. The third section got some of the branch above the x-axis. The whole stinking thing is, right? So isn't all of this above the x-axis? So we have two intervals going on right here. Feel okay with that? I'm going to bust out the straight edge and see what happens. So I know y'all in video land aren't going to be able to see this very well, but still I'm just working from left to right. Our interval is going to start where this thing is to the right of this asymptote, which is at -2. Here's the question. Do you think it's included or not included? Well, this has an equal to bar. Agree? But is this an asymptote or an x-intercept? Asymptote. Can you touch an asymptote, a vertical asymptote? Can you touch a vertical? Can't touch it. So vertical asymptotes are always not included, regardless of what that symbol says. Can't touch it. Then let's keep moving to the right. Where does this thing stop at? So it went here. Where does this thing stop at? Stops at 1. The question is, should we include it or not include it? Is 1 located at an asymptote or at an x-intercept? This is x-intercept. That's where you read the symbol. This one is included in this case. The symbol over here, like this little equal to bar, only has to do with x-intercepts. Right? Asymptotes you can never touch. This thing tells you about if you're including the x-intercept or not including the x-intercept. Okay with that? So then as I move to the right, I'm going to have a gap right here. As I move to the right, so I'm here. Now I'm not touching, not touching, not touching. Here's that other asymptote at x equals 2. Correct? Can you touch the asymptote? Nope. If I move to the right, is it start touching the orange thing? And then how far to the right would that thing go? Wouldn't that go on forever and ever and ever? So we started back over again at 2, and 2 was at an asymptote. Was that included or not included? Can't touch it. And then it went on forever and ever and ever and ever. So that's major weird. This symbol only has to do with x-intercepts. Let's do one more and call it, well, oh, we got 2 more, don't we? Let's do another one. This one's really weird also, due to the fact that this is supposed to be a 0. It is not a 0. So, got to move it over to the left side. How do you move this +3 over here? Subtract it. 4x plus 5 over x plus 2. Then -3 is just off to the side. Has to be greater than or equal to 0. So that's weird. Vertical asymptotes work the same way. Is what makes the denominator 0? What makes the denominator 0? If x was -2. No holes in the graph either because you don't have the same group upstairs and downstairs. Rock on. Horizontal asymptote. We got to do a little trickeration. This chart only works for this nugget, this box. In this orange box is all that it works for. So let's use this box. Tell me about the degrees. Are they the same? Is the numerator bigger? Is the denominator bigger? What do you think? Degrees are the same. Would you believe that's option C in this case, where the degrees are the same? So if we go below here, let's do a little scratch work. Our horizontal asymptote is actually, according to this box, at y equals the leading coefficients over each other. Isn't that 4 over 1? Right? So y equals 4. But that's not our answer. Because guess what this thing does? If you think back to the purple note card, isn't this you're shifting up and down in this case? It's going to move it 3 units down. So you have to use this shift and say minus 3. Who knows what 4 minus 3 is? It is 1. So our our horizontal asymptote is going to be at y equals 1. Because it originally was at y equals 4, but it got translated 3 units down in that case. So we had to move him on down to y equals 1. Oblique asymptote, there will be none. X-intercepts, we'll find those when we start punching it into the graph. But first, let's do this. There is a vertical asymptote at x equals negative 2. Meow, 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 meow. VA, x equals negative 2. And a horizontal asymptote at y equals 1. All of this is graded. And then we will go to the calculator, punch this in, and see what it looks like. We've got to punch in the guy with the minus 3, not the original. So we'll punch. So we got our numerator in parentheses divided by our denominator in parentheses, and then the minus 3. Graph it on the old Zoom 6 window, and we should see exactly what we said, that we've got our vertical asymptote at x equals negative 2. We got a horizontal asymptote at y equals 1, and we're looking for our branches. Our branches are in blue. There is a branch up yonder. Let me change my pen to blue. Branch up here. That's a highlighter. Let's get a pen. Up here. That had nothing to do with the x-axis, because we care about where this thing crosses the x-axis at. This branch has nothing to do with it. But is our other branch going to cross the x-axis at? Looks like at 1. Let's see if it really is. Second, calculate. Choice 5. First curve, second curve, guess. Boom. Isn't that happening at 1, 0? So we'll put 1 on our graph. And we'll graph our branch like so. X-intercept at 1, 0. And do some highlighting. Where do they want us to highlight? Greater than 0. So that's where that thing is above. Above the x-axis, this whole branch is above the x-axis, and the branch from here on over is above the x-axis. You and a neighbor see if you can get the correct intervals of where those are at. You can't touch asymptotes. The x-intercept is where you read the symbol. For this went from negative infinity all the way up to negative 2, not included, even though that's got an equal to bar. This is an asymptote. Starts back over again at 1, and this is where you can include it now because 1 is totally an x-intercept, and that goes to positive infinity. Let me know if you need help with that. I will totally help you. But only one final one. It's nice and factored for us, so that's nice. Is there any holes in this graph? No holes. So vertical asymptote, x equals, whoever makes this guy 0. I got you, Dom. Let some other people think. X equals 1. You okay with that? Horizontal asymptote, you can FOIL this guy out if we need to. We're going to need to anyway because there's going to be an oblique asymptote, so we might as well FOIL that out real quick. So please FOIL the numerator. So I FOILed it, combined like terms, and I got this for my numerator, x squared minus x minus 6. That degree is 2. The degree of the denominator is 1. Check out choices A, B, C. The degree of the numerator is bigger than the degree of the denominator. So bigger, that means we have no horizontal asymptotes. There's none. There could be an oblique asymptote. The only time is if this guy is 1 bigger than that guy down here. Is this guy 1 bigger than this guy down here? So we got to go find that oblique asymptote with synthetic division. What should we synthetically divide by? Whatever makes this 0, 1. So meow, 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 meow. That's why we FOILed this out also, because we needed to figure out what all these coefficients are. So even if you knew the degree of that was 2 already, you still have to FOIL it out so you can find your oblique asymptote. 1, 1, 0. And this stuff doesn't matter because the remainder we just kick out. So y equals whatever this translates to. What does the 1 mean? 1 what? 1x. And no constant, so please don't put plus 0. Isn't it just the line y equals x, which is oblique? I'm going to go put it. It's got a slope of 1 and a y-intercept of 0, so dashy, 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 dashy. It's got an oblique asymptote. We'll call it OA. Y equals x. And it's got a vertical asymptote of x equals 1. Then we'll punch it in our calculator to see what the heck it looks like. So I think using the foiled out version is easier to type in x squared minus x minus 6 for our numerator instead of having to put those parentheses. And then what is it? X minus 1 for a denominator. You should see an oblique asymptote going on. Let's graph it. Definitely got this weird, oblique asymptote at y equals x. And we care about where these things cross the x-axis at. Looks like one of them is at -2, and the other one's at 3. That's where they're at. I can just tell you, save a little bit of time. This one over here is at -2. This one over here is at 3. You could find those with intersection tools if we weren't just trying to speed things up. The weird part is sketching this graph. So let the calculator be your guide, but it's also going to hug the asymptotes. It's going to hug this oblique asymptote, come up through here, and then it's going to just keep curling until you get to this asymptote, and then it's just going to hug it. And then the same thing's going to happen here. If you follow your picture, this thing just kind of starts down here, hugging this asymptote. He's going to go through this x-intercept of 3, and then it's just going to keep on moving on over until it finally hugs that asymptote. They want to know where this guy is less than or equal to 0. So where should I highlight? Above or below? Below. Less than 0. So brown. See if you can get the right intervals. Read from left to right. Can't touch asymptote. From -infinity to -2. -2 is included because he's an x-intercept. Gap. The weird part is people start freaking out on where this thing starts at. They're like, does it start over here at -infinity? Isn't it hugging this asymptote right here? So where does it start from? From 1. Included or not included, since that's an asymptote? Not included. Can't touch asymptotes. Where does this thing go to? If I move to the right, it's going to just stop at 3. And that is included because that is an x-intercept and there was an equal to bar. Nice.